Welcome, everyone. Welcome to the future of artificial intelligence. How will robotics catalyze the human evolution in space? Welcome to the Space for Women show series 36. I'm very excited to welcome our special guests today. I would like to start open with a quote by James Alfred Van Allen. Almost all of the space program's important advances in scientific knowledge have been accomplished by hundreds of robotic spacecraft in orbit about Earth and on missions to the distant planets Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. Robotic exploration of the planets and their satellites, as well as of comets and asteroids, has truly revolutionized our knowledge of the solar system. So today we are going to have a debate about what the state of AI today is and its implication of our lives on Earth and on space, how governmental institutions promote AI in the space industry, and we also discuss how AI will play a fundamental role in the future of space exploration. Please welcome Mr. Bobby Bahov. He's the founder of AI Lab 1 and Space Mining Technologies, and Mrs. Malak Trabelsi Loeb from the UAE. She's the CEO and founder of Vernewell Space Solutions, an international business law and international space law senior legal advisor, and our very special guest and moderator, Ms. Joana Kamenova. She is the Space Solutions Officer at ESA's Innovations and Venture Office, where she focuses on increasing the uptake of space-enabled solutions through activities in business incubation and business applications across ESA's member states. So the floor is all yours, Joana.
Thank you very much, Hien. Thank you for this nice introduction of the topic and of myself. Good afternoon, good morning, or good evening to everyone, wherever you are. It is a real pleasure to be participating in this show of Space for Women today. Personally, for me, it's a highlight because in my day-to-day work, I quite often work with companies that are exploring this intersection of AI and space, especially into other non-space sectors. So I'm really excited to welcome our first panelist, Mr. Bobby Bahov. As already mentioned, he's the founder of AI Lab and Space Mining Technologies, and his background really lies in the intersection between technology and business. He has quite extensive experience spanning across these sectors, from software development to business consultancy, and actually to founding a startup, which is Space Mining Technologies. So Bobby, the floor is yours on this important topic, and I really look forward to hearing your presentation.
All right. So I'm going to talk for a bit about the future of artificial intelligence, specifically within the space industry, and how AI and robotics will help us on all the efforts and on the endeavor of space exploration and conquering the next frontier. So first of all, I'm going to start with a brief overview of artificial intelligence and how we use it nowadays. A lot of people don't realize it, but we use artificial intelligence on a daily basis. If you open your inbox, your email inbox on your phone once per day, there's for sure AI there that works to keep you protected from spam, for example. If you watch Netflix or YouTube, if you listen to Spotify, there's an AI algorithm in the back working on analyzing your behavior and recommending shows, videos, music to you. If you use social media, there's AI that targets or helps the targeting for ads specifically for you. So we interact with artificial intelligence on a daily basis. In some cases, it's even more active, where one can apply for a loan and get a response within an hour because of artificial intelligence. Some banks nowadays are using such tools that help speed up the process of analyzing candidates. On the other hand, artificial intelligence is also in our homes. Of course, probably you've heard of Alexa or Google Home or other such home automation tools and facilities. So AI is everywhere around us already, but it's just starting. It will, in the next decade or two, it will become such an integral part of our lives that Andrew Ng, who is one of the founders of Coursera and also of deeplearning.ai, he says that artificial intelligence will change our lives as much as electricity did back in the day when it was adopted. So we are talking about a huge boost in the technology development in the upcoming decades. And the reason for this is a combination of the increase in computational power that we've got in the past few years, and it's gonna increase even more, especially once we get to the point of having quantum computers massively accessible, and because of the huge quantities of data that we are collecting, storing, and analyzing on a daily basis. Computer software, specifically AI nowadays, is capable of quite a lot of different things. Very often, I'm asked by people, okay, but what exactly can AI do and what it can do? And that's an interesting question because unfortunately, a lot of people have a very wrong perception of what AI is. They have the idea that either coming from Hollywood movies, that AI will start marching on the street soon and gonna conquer us, or on the other hand, slightly more plausible but still completely wrong, they think that AI will start stealing our jobs already tomorrow or in a few months, which is completely wrong. And the reason for that is that AI is just a tool, and it's a tool that will change our lives significantly. It already does, but as I said, Andrew Ng compares it to electricity. But it will enhance our lives. It will allow us to be more focused on the things that matter, and it will automate those things that are boring, repetitive, etc. So how do we relate that to space? So there's quite a few different things happening right now when it comes to artificial intelligence being used on space applications. And one of them, for example, is enhancing the security and maintenance of systems. CubeSats have been becoming very, very popular in the past years, and the whole satellite industry has been growing a lot in the past 5 to 10 years. And with all these satellites circling around, we need a proper automated way in as real time as possible to predict when they will need maintenance, and also to protect them from outside interference. When it comes to specifically to satellites, we also collect a lot of data, and this data needs to be analyzed. That's where AI is already helping. And one very interesting example is, for example, course correction of a satellite. There's already organizations out there that are using AI to help a satellite navigate properly and avoid obstacles and space debris, for example, or other satellites. Of course, there's also anomaly detection. We use AI to observe how a satellite is behaving and how we can, if there's any problem, to detect it as early as possible. But what do we do with all these satellites? Well, most of them collect information, as I said. And this is where one of the other application comes in, and that's Earth observation. And Earth observation has also been a field that has been growing rapidly in the past few years, mostly because of all of the data that we can collect and the huge amounts of information that we can store and analyze. And nowadays it's being used, for example, as for predicting volcano activity, or through the innovation programs that we organize, we have run projects where Earth observation and artificial intelligence, the combination of these two technologies, have been used for detecting and analyzing the health of coral reefs. So it helps us preserve coral reefs better. There's also applications in urban planning that AI helps a lot with. Yeah. Then there's also another interesting example of a project that we had during our one of our open innovation programs was detecting sand theft using Earth observation and analyzing the satellite images with AI, and how the coastal region changes and detecting illegal sand theft. Then there's, of course, the space observation itself, so looking the other direction. And we are already using artificial intelligence, for example, to observe and create models of asteroids, to measure their shape, size, and even their spin rate. AI helps us to do that. Another very interesting example is detecting exoplanets. An exoplanet is a potentially it's a rocky planet in a potentially habitable zone within a neighboring star, and the way to detect those is very difficult in traditional terms, because the light of the star is so bright that it completely obscures the light that a planet would reflect. So the way we find stars is, planets circling stars, is when there's a small dot that covers a small part of the light coming from the star, and this is when the planet circles around the star in its orbit. So AI helps us detect these small changes in the light coming from the stars. You've been hearing probably a lot about, in the past few years, about different exoplanets. For those of you who are interested in astronomy and space, different exoplanets being discovered. Interesting thing is that AI helps with that. Here in the Netherlands, I even have a friend who is working on his PhD to create a smart telescope mirror controlled by AI to help detect and observe exoplanets. So we are looking at, with our satellites and with all our systems, not only towards Earth, we are looking towards outer space as well, and AI helps a lot with that. Then there's also manufacturing. We use AI to help us not only manufacture satellites, as I mentioned, but also even rockets and rovers. There's various ways to do that within space mining technologies. In my startup, one of the projects that we are exploring is using an automated way, using an AI algorithm in combination with other tools to help speed up the process of designing such vehicles like rovers tremendously. Then there's also optimizing the whole manufacturing process once the design is ready. And a very interesting development is the digital twins technology, which also is based on artificial intelligence very often. And the digital twin is the possibility to create a 3D version of a system. It could be a rocket even, for example. And through this 3D twin, the digital twin, we are able to design it better without having to manufacture it multiple times directly in the hardware. But we also can predict how it will perform. We can see its level of the different aspects and challenges within the production, including, for example, how it will be the different versions of upgrading from one to the other. All of this is enhanced by AI. So this was a very quick overview of what the current state of AI in space is. Now I'm going to go a bit more into the sci-fi zone, because obviously in the short term we can predict what AI is going to do, but In the longer term, it will be a bit more difficult, and there's quite a few different things that we can think of. For example, building on what I just said, automating systems in not only in manufacturing but also the operations of a system would become a reality in the near future. Right now, we need to send, if we want to send astronauts, for example, or machines and rovers to space, we still need to for majority of the time, we need to control those machines manually. In the future, most of it will be autonomous. An AI algorithm will be controlling the rovers of future space missions, even more so than now. Because the farther we go into our space exploration, for example, even in the solar system, the more difficult it becomes to have real-time communication. There's already a delay between Earth and Mars, and it will be even bigger if we want to explore the moons of Jupiter, for example. So the way to do so will be to send autonomous rovers or drones to collect samples, to analyze them, and bring them back. Then there's also life support. For all the future missions, and especially if we want to have permanent outposts on planetary objects like the moon or even on Mars, we need a very sophisticated life support system in place to help astronauts live in this really hard and survive in this really harsh environment. AI can help a lot with that by analyzing in real time all the conditions of the astronaut, how they feel physically, and how they're performing, especially when they are outside of the habitat, for example. And an AI system can help protect the astronauts from accidents or even from all the problematic and challenging aspects of being in outer space. And then for the far future, there's even more interesting things coming. For example, automating telescopes even further than what I just covered, that we already use Earth-based smart mirrors. In the future, we'll have huge telescopes like the James Webb telescope, which will observe the farther into the outer space. AI will help us not just detect what's interesting on the images there coming from the telescope as right now, but it will help us control the telescopes in a way that it will just not be possible manually. Then there's also, going further on the autonomous rovers and robots aspect, there's this right now, this is just a theoretical concept, but in the future we might even have self-replicating rovers or drones, or the so-called von Neumann probes. These are robots that can, so it's manually created, the first version of it is manually created by humans, for example, and then we send it to a planetary object. It could be an asteroid, it could be another planet or a moon. It collects the necessary resources to reproduce an exact copy of itself. And sometime in the future, it will be able to create one after the other, a whole fleet of such small robots. Those robots will be able to create a habitat for human astronauts to come and occupy before they even arrive on the planet. So it will speed up the process and reduce the cost of space exploration tremendously. All this because of the adoption of artificial intelligence. And finally, one interesting example would be terraforming space objects. Right now on Earth, we are already using artificial intelligence and smart drones in farming, and we are basically terraforming Earth using AI nowadays. It's used for fertilizing, for smart fertilization of the soil. And in the future, we might send such drones to Mars, for example, or to even further away. So this is, most of this is still theoretical because we are far away from it, but because of the adoption and development within the AI industry, we'll be able to speed up this quite a lot. And I personally am looking forward to, to this. I believe it will happen in our lifetime, at least to be able to explore with robots the outer regions of our solar system. So even more than what we currently have. And AI will speed up not only technological development on Earth, but also in space. So this was a very quick overview of what I'm looking forward to when it comes to AI in space and what I believe will the future holds.
Well done, Bobby. Thank you very much for your insightful presentation. Myself, I always find topics on AI in combination to space fascinating, but also quite different to flesh out with examples of what do we mean exactly. So I really liked the examples that you provided of the crossover of AI and space in the downstream sector, with the coral bleaching, and of course with other natural resources such as forests. Yes, and all the natural resources really. And of course, some of the upstream examples with manufacturing and finding new planets. So thank you very much for this insightful presentation. Before jumping with to the questions, of course, we have our second panel member for today. And you're very well familiar with Malak for those of you that attend our meetings. So Malak is the CEO and founder of Vernewell Space Solutions. And she's actually another great example of a multidisciplinary professional with her experience very grounded in international space law, new space law, business law, but also on the topics of international relations and diplomacy. So Malak, I'm really looking forward to your presentation. Please, the floor is yours.
Thank you so much. Thank you. Good to see you all here again. And I would like to share my screen. Perfect. Meanwhile, I would like to say to Bobby, thank you so much for the great presentation. And actually, my presentation is going to be a little bit different. There is, of course, whoever knows me, futuristic approach into it. So it is inspired by different perspectives, addressing technology advancement, as I do all the time. It's used to enable our evolution beyond the Earth boundaries and addressing the risks associated, governance also, and how to mitigate these risks and balance the various interests to achieve the socio-economic development without deteriorating the space environment while keeping space use for peaceful purposes. And here, my presentation will be on space robotics, enabling humanity's evolution toward becoming multiplanetary. So I start. So once upon a time, space robots were science fiction. Oops, something went wrong. Yeah, so, and there's the question now, people that are asking, astronauts versus robots, and also asking the question is like, what we're gonna call them? And so many questions, and we will address them in the challenges later on. But as per NASA, there's something, it's very, I think a lot familiar with, what they say when we talk about astronaut versus robots. It's saying they can survive in space for many years and can be left out there. No need for a return trip. So in that perspective, we say, why do we send robots to space? Well, to explore human, due to also human biological limitations. It's less expensive to undertake tasks that are almost impossible for humans for now, to make in the harsh space environment. Of course, we have radiation and extreme weather, and always, of course, our biological issues that they're not solved for now. And I would address, because Bobby addressed like the aspects of artificial intelligence, but I would address robots versus artificial intelligence, because some people they mix between robots and artificial intelligence, and they think all robots are artificially intelligent. So here the question is, what is robotics? So robotics is the branch of technology dealing with physical robots. Robots are programmable machines. They carry out a series of actions autonomously or semi-autonomously. Robots interact with the physical world via sensors and actuators. Artificial intelligence, in the other hand, it is a branch of computer science, so it involves the developing computer programs to complete tasks that would otherwise require human intelligence. AI algorithms deal with problem solving, learning, perception, language understanding, and or logical reasoning. So what are artificially intelligent robots? So not all robots are artificially intelligent. So artificially intelligent robots are the bridge between AI and robots. Intelligent robots are controlled by AI programs. Non-intelligent robots, in the other side, functions are limited. So here we say that AI algorithms are critical to enable robots to carry more complex tasks. So here I will address the robotics in space. So here we have the NASA. NASA has been investigating Mars with rovers since the Pathfinder mission landed in 1997 and deployed a small rover called Sojourner. Here we see the Curiosity rover takes a self-portrait on Martian sand dune. And these are available at NASA website. So NASA has been deploying rovers to explore Mars. Mars rovers such as Curiosity, Spirit, and Opportunity have been playing a crucial role in human space endeavors. Space robots come in all shapes and sizes. They are human operated using long transmission radio waves. The space shuttle's Canadarm robot arm first flew on the shuttle's second mission in 1981. So the International Space Station is home to the larger Canadarm2. And here we go to the robotic arms and its use. And I've been addressing a lot on-orbit servicing and their use and their future use to enable a new, let's say, sector within the space economy. So robotics arms enable on-orbit servicing, which we call OOS. OOS consists of upgrading, repairing, and maintaining, assembling, refueling, and commodities replenishing, orbit locating, and debris mitigation. And very, very important, the last part, because debris mitigation is very, very important. So despite that OOS has been only conducted by governmental entities, commercial actors are achieving great improvement in developing robotic OOS to be used within the next 5 to 10 years. Such achievements will be game changer in the satellite industry first, which will shift this industry by extending the life cycle of the satellite, mitigating the risk of space debris, and enabling building space infrastructure. And this is these points are very important when we talk about becoming multiplanetary, because actually we will not even be able to go to the next stage of becoming multiplanetary if we do not have space infrastructures that they allow us to move beyond Earth orbits, and also very, very important for the mitigation of space debris. And actually it's a risk, and I read in some studies and articles, they say that space debris may become, if it's not, this issue is not mitigated, it may become an existential risk for humanity to move forward. And actually, we depend on satellites, and our economies also depend on the use of space. So can it be an existential risk? For me, I would say yes, but some people, they would say no, and it's debatable. So space infrastructure is necessary precondition to extend to Mars and beyond. OOS could be helpful to the insurer. Of course, space insurance is very, very important in our space endeavors. So OOS could be helpful to the space insurer to mitigate possible risks and to extend to the life of the space resident, whatever is in space or orbiting around Earth. We call it also space resident. Once it becomes a reliable technology, because actually now OOS is also considered as technological risk when we make the risk assessment for the space object. But prior to extensive trials, it can cause further risk to space assets, and that's another issue right there we will talk about later. So here I focus on in-orbit servicing because, as you see here very well, it can create a new cycle within the space ecosystem, within the space economy, which will reflect on our global economy here, which will be also, like I said, mitigating risks and so on. But also it will give, let's say, this push to the economy in order for investors to go further and invest extensively in the future space endeavors. So here we have debris removals, transportation, here satellites, human exploration assistance, which very, very important. Assembling, it's very, very important when we talk about assembling space, like assembling different, let's say, pieces for infrastructures in space, because the future will be, you know, 3D printing and assembly and everything. And this one, it happens on using the in-orbit servicing or on-orbit servicing, and also using robotics when we are talking about Artemis program or the future, let's say, Elon Musk settlement, as he's very, very keen to be on Mars very, very soon, within the next 2 to 4 years. And of course, refueling is very, very important for the space missions that they are beyond the orbit. And of course, we have recycling over there. So that's a whole cycle. And here, when we go to this very, let's say, complicated, let's say, a picture here, we have who are involved into the on-orbit servicing, the maturity curve. So here we have the operational under development technology maturation path. We have the future technology maturation path. So here we have technology, robotic arms are already there. Vision systems, fluid transfer system. Actually, robotic arms, as I say, it's used in the space station. And we have OOS-friendly versus autonomy. So we have some commercial OOS. So we have some companies that are trying to get their, let's say, their technology matured, because of course, what they trying to do is to start with the satellite servicing and with the satellite related issues to be fixed. But the challenge, which I will address later, one of the challenges is how to have that robotic arm or the on-orbit servicing to be compatible with the satellite itself, because actually, if it's not compatible, it can cause a risk to the satellite. So the new, let's say, wave of satellite production, or they should be, let's say, compatible with the OOS, and this is what is the future is going to bring for satellite industry. So we have here some future commercial activities what using OOS. We have insurance inspection, refueling, repairing, upgrading, modular SPS. And here we have who's active right now in the OOS activities. You have, of course, DARPA and SureSat and other companies. So when it comes to maturity, we have commodity markets. It will be involved, fully modular systems. We have on-orbit manufacturing. We have large structure assembly. We have leased platforms. So startups and people, they want really to go further and be there and anticipate this maturity curve right there and be there. Actually, it's a good start to think about technologies and activities within this market, because it's going to be very, very good sector. And here the challenges. Okay, so actually when we talk about challenges, we have always technology is one of the main challenge related to the, actually it's a source of hazard in space ventures. So from let's say risk assessment, always the problem is assessing the risk or assessing risks related to technological, especially new technology. What we call it always, it's untried technology, and it's the biggest source of hazard. And actually, I wanted to give an example how technology in general is source of hazard, whatever it is, artificial intelligence or it's any other type of technology. Actually, I give the Challenger tragedy as an example. The U.S. Challenger, the accident was due to manufacturing anomaly. The U.S. investigating committee stated that the failure of the seal joint around the O-ring, a piece of the rocket boosters, caused hot gases leak out of the rocket booster. So consequently, we had the leakage has initiated flames bursting out to burn the external fuel tank, which exploded 73 seconds after the liftoff. And when we talk about technology, always is the biggest source of hazard, especially when the technology is not tried, because we don't make trials here. Actually, we send to outer space, and all is done based on risk assessment. Here, the other challenges related to AI in general, or any activities that there are taking place in outer space. Ethics, of course, is very, very important. We have sustainability issue. We have governance, liability, insurance, sentient right. And here, when we talk about sentient right, it is the new, let's say, talk that everyone is we have two different waves. People that are very scared about how artificial intelligence could be an existential risk, and the other side, people or some how I'm going to say sentient right activists. So they are defending the robots' rights and sentient rights, because actually they say robots will be enslaved, and how it can, it will not happen, because if it would be intelligent, it means like it could be compassionate, but also it can be, it has, let's say, sentient right. So here there are two versions, and actually maybe being a part of the team next time when we speak about artificial intelligence, we invite some professionals. They are into ethics of artificial intelligence, addressing this issue that it is very important. And the other versus the sentient right activist mindset, to understand what is it exactly and shed light on that matter. Thank you so much, and I'm done.
Thank you very much, Malak, for this virtual applause, for this very insightful presentation. I can already see how your different background is putting a little bit of a different twist. I really enjoyed bringing us back a step, defining what do we mean by robotics, AI, and really the merger of the two. Very important to give insights for future applications. And of course, a great example on the robotic arm. And on my behalf, I can say that, of course, all these advances within the space sector, within on-orbit servicing, these are things that could quite easily be transferred back to Earth. In fact, very recently, maybe a couple of months ago, we accepted in one of our business incubation centers a very promising startup operating in this area of soft robotics and the robotic arm, but really looking at the quite different sectors, industrial laundry services. So seemingly from a super exciting sector, the technology remains exciting, but it's implemented in a very, very day-to-day sector. So these are some of the examples that we also can draw from space on Earth. And now, of course, it's question time. So the most exciting part of interaction. I have a couple of questions here, and Bobby, I will start with you. You spoke quite a lot about the state of AI, and you provided quite a nice overview already. But what are some of the implications actually on our life, both on Earth and in space?
From the adoption of AI, you mean? Well, it makes life easier as an automation to artificial intelligence at the moment with its current state is helping not only businesses and industries, but also our personal lives. As I said, as I gave examples with home automation, for example, or even personal assistants like Siri and the Google Assistant. And in the upcoming years, in the short, just in a very short term plan, there will be even bigger integration of these smart assistants in our lives. And for example, AI will become so ingrained that at some point, maybe in a few decades, we'll be looking back at our lives and we'll be thinking, wow, we did live quite differently without AI being such a big part of our lives as it will be in the future. So yeah, a lot of automation. It's a tool that will allow disruption of a lot of industries. And very often people say that the competitive advantage of that artificial intelligence creates for a business is so big that those that are not adopting it and are lagging behind will be left out. They will literally be disrupted and die out. We are just touching on the tip of the iceberg right now, and this will go a lot deeper and faster in the upcoming years. So yeah, AI is here to stay.
So thank you for this. So maybe a follow-up question, and Malak, if you can tune into this. This is actually coming from the chat. It's raising around one of the concerns around all of these implications. It's the impact on our brains and potentially taking away our ability to make independent decisions. So what is your view around this?
Well, there is a wave of transhumanism, and it's going toward post-humanism. And the thing is, like, when we talk about that, and the word it has become a jargon. Everyone is talking about it, but actually it's been not well understood. We became already very dependent on machines. We became very dependent on technology. Actually, when my son is 12 years old, that he's walking, he doesn't see around him, and he has his phone in front of him, and he's so much attached to the phone. If I will ground him, really, very, like, he will go crazy because I take away his phone. So it changed our decision. And here there's a problem, the biggest one. When it changed our decision, what is the information that we are taking from that device? This is the problem. And we've seen that our life has been changing so drastically because of information, because of targeted marketing, because of everything. Politics, diplomacy, everything has changed because of our, let's say, dependency to our technology. And actually, as Bobby said, that AI has become very, let's say, everything depends on it, even though it's not at its maximum use. It's not at its, like, AI is not, let's say, very advanced right now. And so far, it's changing our life. We are targeted through algorithms, and this is how our lives are changing. So yes, it is influencing our decisions. Our businesses depends on them, because also we see at it from entrepreneur side. So if you want to make marketings, if you want to, let's say, look at it from strategy for business, you cannot continue a business today without integrating a strategy that includes artificial intelligence application.
Indeed. So I guess this change, of course, is something inevitable, but we as a society have to reflect on how actually do we respond to it and to what extent. So thank you for this. And I have another question, which I will address to both of you, because selfishly, it's quite important for me as working in one of these intergovernmental organizations. So how can governmental institutions promote AI in the space industry? Let's say, well, Malak, you can kick off again for a change.
I will let Bobby also talk, because and you, of course. Now I'm going to make the moderator for you, so like that I hear your insights. Actually, for any activity, any sector, and especially sector that it's emergent, it's very important for the government institution to have a vision, to have a strategy, to have foresight in order to keep up with the race. We are racing today. AI as space, they become soft power. And actually, if a government is not including that within its foresight and strategy, it will not, let's say, keep up with the other nations. Very important. And of course, like technology transfer or AI-based technology transfer, it could be a potential risk for national security. So the country and the government need to be aware of that, and they actually, now we see how most of the governments and institutions, they are making different, as you said, different, let's say, initiative to get AI going, and especially space. So we have the space race, we have the quantum race, and we have the AI race. And all of them, they are connected, because to go to space, we need technology. To have AI, advanced one, we are hoping for quantum computers and communication and everything get mature. And all they are together. And here I will cite the UAE strategy for artificial intelligence with the foresight. And within the next 10 years, actually, the UAE placed itself with the foresight of the leadership here to become, let's say, the hub of artificial intelligence. And actually, we see it today. We see, we go to clinics and we find robotics in clinics. We find that everything is based on artificial intelligence. And it's very, very important, because, like I said, it's a soft power also.
Yes, thank you, Malak. Indeed, it's a multi-race of many technologies within many sectors. The way we approach it within our program, is a space solution, is through different routes to the different types of companies. So for example, in our business applications program, we would target companies that are non-space, but are looking to use some space data or technology. And there we have a little bit more of a foresight and trend-setting ability to set the topic. So we've had different calls on artificial intelligence for good in the health sector, or we've had different calls on robotics already to see what is out there, what are some of the ideas. And this is more of a kind of top-down approach, if you wish. And a little bit more of a bottom-up, it's through our business incubation centers, where many of the companies are already suggesting ideas, of course, with artificial intelligence. So this is a little bit bottom-up. But I would be interested to hear, Bobby, what else can international organizations and national governments be doing?
Yeah, thank you. Well, I believe that the space sector will be privatized in the next decade or two, and big governmental space agencies will have less of an executive role and more of a supervisory role. We are already seeing such a movement with SpaceX, of course, and a lot of other new space companies. I think that by the end of this decade, this will become the norm, and especially going forward, it will be private companies that lead the way. Of course, we need better legislation and regulations to do that. There's a lot of problems within space and within space law that prevent such companies to operate freely. Fortunately, there's been some movement here in Europe. Luxembourg was the first country that introduced laws allowing for private space utilization of resources, for example. So there's movement in that direction, and it will get there, especially once we start having permanent outposts on the moon, for example, for research purposes. It will become necessary for governments to actually come together and build the proper legal infrastructure and framework for this, which right now is missing.
So thank you, Bobby. Yes, I agree that these roles of established space agencies would change to more of a facilitator, enabler, to give way to the private companies and hopefully the many startups that are coming to the space sector. So here I would like to look into Hien and Tiara. Do we have time for one question from the other channels?
Yes.
The question is, what are the panelists' favorite science fiction movies, books that they would suggest for others to watch and read? From Barbara.
Well, I can start. For me, the movie with Matthew McConaughey, Interstellar, is one of my favorite movies of all time, and definitely my favorite space movie. It's more of a, it touches upon a lot of theoretical concepts, but yeah, I recommend it for those who haven't seen it.
For me, it's not a movie. Actually, yeah, Star Wars, but I don't like so much because it's based on wars and things like that. And I always say sci-fi keeps our children dreaming. They give them hope. They give them future. So we see right now sci-fi are based on fear. They are scary. They are showing or reflecting a dark future, which reflects on people's view to the future and grow their fears. And this is very I always say this is not the way how sci-fi needs to go. And actually when I was little, when I was young, I was reading in French Jules Verne, and that's how I was dreaming about the future, about space, about all this. And I remember also the series of Stargate. I grew up on Stargate, and I love that one because actually extraterrestrial, alien life, and jump from dimension to another or from place to it was amazing. And also, Martina, I would like to say about you're saying that we became the customer became a product. Also, I think. Yeah, this is a problem with the ethical use of technology and the ethical use of AI, because we are actually they are mining our data without our consent. Sometimes the consent is done legally with small words that even no one can read. And actually, when I go to those terms and conditions, I find that the terms and conditions are violating human rights. And actually, this is another point with the ethical use of technology. We are on social media platforms, and actually we are either being violated our rights or given away our rights without knowing it. And actually, in both cases, it's not ethical at all. And that's something that it needs to be fixed.
Thank you, Malak. Last question from Martina asked, do you think the robots will replace the astronauts' job?
Robots are already not replacing astronauts, but working alongside astronauts. Once again, it's a tool that just allows us to operate faster and more efficient. Going forward in the future, definitely there will be even more usage of smart robots. But this is not in the replacement of human astronauts. This will allow human astronauts to survive in outer space and to go further. Especially if we want, as I said in my presentation, if we want to establish posts on planetary objects like the moon or Mars, or even going further away, we definitely will need automated systems to allow that. Without AI, it will be a lot more difficult. So it's not going to be a replacement. It will give us the opportunity to do so.
Thank you, Malak. Do you want to add on this?
Actually, it's I agree with Bobby, and I said it before. The question is robots versus astronauts. Actually, I think the robots will prepare our arrival, let's say, for the future. So yeah, and actually we will not be astronauts anymore. We will be Earthlings on Mars, or we will be Earthlings on other planets. So the future, the next 100 years, I hear futurists what they are thinking, and actually I think I understand what Elon Musk trying to do. And actually, he has SpaceX, he has the Boron company. So the Boron company, it will be deployed later on, the machines along with robotics to make the infrastructures on Mars. I don't know if Elon Musk will see that coming or not, but his legacy will.
Thank you, Malak.
So thank you very much, Malak, for these last insights. Of course, as it happens, we have so many questions, but we are very near completion. Thank you both. It was a very insightful, futuristic debate for me. And always the human and ethical aspect is very interesting to filter in within the technology and innovation. So it was a pleasure, and I would like to pass on to Hien for some concluding remarks.
Well, thank you everyone for this great panel. Thank you, Joana and Malak, backing up. I apologize for Carla. She couldn't be with us today. So, and thank you, Bobby. And thank you everyone who joined the show. Next week, we have space microbiology with Professor John Kiss moderating, and Dr. Christopher Lars, and stay tuned for that one. And everyone, please do stay safe, and we hope to see you next week. Thank you, everyone.